Neometrics Technologies. Today we're going to do a presentation of the Creaform HandySCAN 700. The HandySCAN is a completely handheld system. It uses targets applied to the part or the environment for its reference system. And these targets are how we achieve a best-in-class 30 micron or 1 2/10,000ths accuracy spec. Now notice we don't have any arm, no mechanical arm or anything like that attached to the scanner. We're just completely freehanding this. Notice we can get both parts of this wheel here. So if I want to come to the other side, we'll spin it and capture that interior data.
Now you may notice that the HandySCAN's laser projecting is quite a bit different than 3D scanning technologies of the past. We're using 7 laser crosses, which give us a class-leading scanning speed of 480,000 points per second. So we can gather lots of data extremely quickly and minimize our scan time. We can also take that 7 laser cross system and turn it into what we call a single line mode by double-clicking a button on the back of the scanner. Now what this single line does is it gives us one laser line that does not require both lenses on the scanner to see. So it only uses whichever lens is actually looking at and is reflecting back, their single lines reflecting data back to. Allows us to very easily get into these tight areas, these holes, right here, the through bolt holes on this rim, into crevices, things like that. And then we can, of course, switch back to our multi-line mode by double-clicking that button once again. The multi-line mode is the one that you're going to use for general area coverage. It's the quickest way to gather the data, and it's the most accurate way to map out the targets that are telling the scanner where it's moving around in space. So as you can see, we're on the left side, we've got a depth of field indicator. As you hold the scanner too far away from the part, it's going to show you blue. And if you get the scanner too close, it's going to show you red. So you want to kind of float right in the middle where it's green. That's the optimal scanning distance from your object. Another huge advantage for Creaform is the fact that their entire scanner suite have no moving parts internally. So no fans or anything like that. They've got a very large temperature range in which they can work, and they're all environmentally sealed. So with the compact form factor of the scanners themselves and the HandySCAN weighing less than 2 pounds, you're ready to take it anywhere in the world. Now, the software we're scanning into here is VX Elements offered by Creaform, so this comes with any scanner that they offer. You see here we're going to actually process our mesh. I've sped it up a little bit. This process is about 1.5 minutes for this part. So we're actually going direct to mesh, so there's no point cloud conversion like you would traditionally have with other units as well. This is going to spit out an STL or OBJ automatically. So we're finishing up here, and we'll see our final mesh. And here we are. We obviously have a bunch of data missing. We've got all these voids in our scan. With Creaform's VX Elements software, it's very easy. We just open the scan session back up and just fill that data in seamlessly. We'd have no data patching or alignment or anything like that. And once we complete the painting of our part, we just reprocess that mesh, and what we end up is with our final file. Here we are. And if I turn the triangles on to better show the mesh, we can see just how beautifully Creaform constructs this file. Now with the part that we can't just freely flip over and scan both halves, we're going to have to do them in 2 sections. So here with this aircraft bracket, I've gone ahead and targeted up this turntable, and we'll take a full scan of this bracket, this half. Once we're done with that, we'll flip it over and we'll do a 100% scan of the other side, making sure that we've got some overlapping data. Here I've actually got targets on the part itself, and that's very useful. They aren't enough to actually scan the part with, but we can use them in our merge and align both halves based off of those targets, make a very quick and very accurate alignment. I've gone ahead and sped this process up again just for some time savings, but what you see here is we end up with our merged mesh of the bracket. Now, VX Elements does a great job of mitigating file size by leaving areas of high contour sharp and then reducing the triangle count on areas of low contour.
Creaform scanners excel at capturing data that would typically be considered unscannable by other technologies. As you can see here, we're scanning this black anodized part without any sort of surface prep, and it's capturing the data just fine. So on a part like this, where we don't have any room to target it, we'll just use the table for our reference system and use Creaform's own best fit merging option to align the two halves together. Now that looks just about perfect. We can also do parts with varying surface textures and colors, so this is great for artwork, especially painted. You can see here we've got a very high dynamic range that we can capture with the unit. So just whole fill everything on this dragon statue here, and he's ready to go straight to the 3D printer, auto surface, or ready for 3D sculpturing.
All right, so our first actual example is going to be done in Geomagic Design X. So this is our reverse engineering software. What I'm going to do to start is run this auto segment wizard. And what this wizard does is it analyzes the mesh and it breaks up that mesh into a whole bunch of usable regions. So you can see if we hover over these regions here, it'll recognize them as planes, revolves, cylinders, freeform surfaces, things like that. Now, they're not physical CAD surfaces. They're just on the mesh, but what we can do is use them to extract our CAD surfaces from them. If you got to do any editing, you can certainly merge a few together like I'm going to do here to make one big revolved surface. It's just going to help me out with the modeling.
So we're going to start with the revolution wizard. We're going to use it to model the main rim. What we can do with this wizard is select the regions that bound the geometry we're looking to model. So we're going to select all the way around the rim here, every single region. Okay. Along with the revolution axis, we want to make sure we have it constrained to this main axis here. And when we run the wizard, it's going to create a sketch automatically and revolve that sketch around that chosen axis. And you see, just like that, we've got the rim modeled.
And what is nice as well with Design X is we do have the ability to go back and edit the sketch and the revolve if we need to tweak things a little later. But next we're gonna model this long main spoke here, and we're gonna do that with another method called the mesh sketch. So mesh sketch is a regular sketch. We're gonna select this plane, and what this plane is gonna do is bisect the mesh and give us a profile which we can trace essentially. So here we've got our profile, we're going to localize it a little bit, and we're going to get this pink reference polyline. Now the bottom, this little cutout is a pocket. That's going to cause us a little bit of a problem, but we'll fix that here in just a minute. We'll start by sketching the top profile, which we can do with our sketch entities here. Now you can see we can snap entities right onto those pink reference polylines. They're basically trace lines. We're going to finish up this top profile with a few tangent arcs here. Okay, and then I'm going to square off the bottom just to make sure it's inside of the geometry, the central hub, which will be another modeled feature a little bit later. All right, so let's get that squared up. And now we're going to have to go and sketch the bottom of the spoke.
So now I'm going to go back into my sketch setup, and I'm going to revolve that profile just slightly to where we get the bottom surface, good profile sketch of it. Now we can go right back into the sketch and continue on what we were doing. I'm going to grab my my arc tool again, and we're going to fit a few more here to the bottom. A couple of these hard edged lines. So you see we're just snapping onto those segments there. And now we're going to trim them all back up. So let's grab our trim tool, and we're going to make sure all these endpoints connect. Now with a smart dimension, I can go back and edit the angle here, so I can make it an even 150 degrees, more like what the design intent would be. And then we're going to close this profile with a fillet on this area. So you see I can drag the fillet into place, and then again go ahead and change that fillet number to the next round number. All right, now that we've got everything sketched up, we're going to close our boundary here, exit our sketch, and create a standard revolve. But we're not going to revolve it all the way. We're just going to do it part way, just so it bounds, just so it extends outside of the boundaries of the spoke here. All right, that looks about right. Okay, and now we're going to actually create some surfaces to trim that back. So I've used the mesh sketch function to create all these sections off camera, but we're going to use them to create a surface loft on each side. So we'll go ahead and loft both of those down, and then we're going to use the surface extend to make sure that the edges of those extend past the CAD file itself, and then we can use that for trimming. So here we got one side. We'll go ahead and do the other. Okay. And then we're going to use both of those again to cut the center portion out of this revolve, and that'll make up the body of our spoke. We'll go ahead and keep that center section there, and there's our spoke. It looks pretty nice. Everything's overlaid really nice with the scan. Now we just need to add a few fillets. So we'll do this top fillet here, and that should just about do it. So that looks pretty nice. We'll go ahead and move on to the next feature. So now what we have left to do is create our second two spokes. I'm suspecting these are mirror images of each other, so we'll find that out here once we create one and I mirror it over to see if it matches. We're going to do this one a little bit differently. Instead of creating lofts, I'm going to use DesignX's mesh fit surface feature. So mesh fit surface is basically an automatically extracted single patch surface that we can grab from these regions that we created earlier. We'll apply a surface to each of those regions and then trim them all back, as you can see we're doing here. So I'm going to make sure they all trim up nicely together, and that's going to create the boundary, or basically the surfaces, all of our surfaces of our spoke. Now if we take that and mirror it across this plane, we can see that it's extremely close. So for design intent purposes, we'll go ahead and use that as a mirrored part. We'll revolve our hub here and then make a circular pattern with this surface I made for the lug bolt cutout and our three spokes around the center vector of the wheel. There we go. So we've got all of our features ready to go, and we can merge those together with our outer rim, and that'll create one singular piece which will make up the bulk of our CAD modeling. All right, now that we have one single CAD file, we can continue with the last steps of our modeling. To begin, we'll cut out the pattern bolt recess cutouts, I should say. So we'll cut those out in the main body here, and then we'll hide those, and what we're going to do next is use those same cutouts to create a mesh sketch on the inner portion that makes the actual through holes for the bolts. So we'll click on that surface there and go ahead and get our nice cross section. That way we can extract our reference polyline that we can at this point trace with our sketch tools and create those bolt holes. There we are. Now we've got our circles there ready to go. So just like before, we're going to take the circle tool and just click on that circle. You see it's going to apply an automatic circle there. We can make it any dimension we want at this point. So go ahead and make it 11¼ millimeters in radius, and then pattern that just like we did in 3D with the bolt recess surface cutouts and the spokes, but we're doing this in 2D with our sketch. And now we're going to extrude those profiles and make a through cut. All right, so now what we got left to do is create a bunch of fillets. So we're going to create the fillets around the boundary here. We're going to create some more fillets around these spokes. Create more fillets and more fillets, and finally a few more fillets. That should be the last one right there, so everything looks pretty good. All right, and that's our completed CAD model. So looks like we've got all the features modeled there. The last thing I want to show you is what's called the accuracy analyzer. What's very nice in Geomagic Design X is that we can compare our CAD file to our scan at any time during the modeling process and see how well we've
adhered to that design. So that looks pretty close, and that's going to wrap up our reverse engineering example. I'm going to move on to Geomagic Control X, which is the inspection portion of our 3D scanning presentation today.
So this is we're actually going to compare scan data to this CAD file. I'm going to import that scan data now, the bracket we scanned earlier. You see right now it's unaligned. I'm going to run an alignment between the two and just do a best fit here. All right. So first thing we're going to do is add a few dimensions in 3D space. I'm going to do a linear dimension between these top two cylinders here. So you can see we can just grab the faces and click as our final dimension. We can do something similar with the angle between the two side faces here. So grab the faces, drag the dimension out. It's going to give us our actual angle. And then last thing I'm going to do is a radial dimension here on this bottom circle.
Or I should correct myself and say cylinder. So we can position these dimension flags anywhere for our report generation later. Now, just like we grab those dimensions in 3D, we can also do the same thing in 2D. So I'm going to grab this surface here and create a cross-section through our CAD file, and this will compare the scan to the CAD at this particular cross-section. I'm going to grab these two circles here and put another linear dimension between the two. I'll constrain them to one particular axis. There we go, and that's going to give us again our real dimension of the scan file.
So last thing we're running here is this 3D compare tool. This is going to compare the scan to the CAD surface and give us the real deviations. So along with this tool, we can also choose areas of interest. So if we see this is a little bit high over here, we can go ahead and flag it along with maybe an area that's too low. And that way you can very quickly identify areas of interest.
Just like before, we can drag those dimension flags out to make a very nice looking screenshot for our upcoming report. Okay, so we're all done inspecting our bracket. So we'll go right up to the top of the page here and click Generate Report. In this window, we can choose whatever template we would like. Here I've got a custom one set up, and then we can also select which features we'd like to exclude. And here the initial alignment's trumped by the best fit. So I'll go ahead and just remove that redundancy from my report. You can see here we've got our title page, we've got our 3D CAD file, the nominal data, we have the 3D scan data from the HandySCAN, we've got our alignment between the two, so there's our best fit with alignment statistics, our 2D cross-section with that single dimension. Next up is our 3D compare color map with those 3-dimension flags, and then finally our 3D compare dimensions. And that's going to wrap up our inspection example here today.
Thank you for your interest in 3D scanning. Today we went over 3D scanning basics with the HandySCAN 700, reverse engineering, quality control and quality assurance, and product development. Go ahead and click the link below. We'd be happy to bring the equipment to you and show how we can integrate this technology into your workflow.